Hello, we are glad to show our plugin PCC, which automatically writes the codes. We install the Aerospike database on VMware. The IP of the virtual machine should be set on the preference page of PCC. After the IP is set, we could use our plugin PCC directly. We prepare 3 Java files. The currently being edited Java file is full of features of Java 8. Due to the very few resources of codes of Java 8, this Java file consists of the code fragments extracted from different Java sources. The goal of this file is to show that our tool can generate the codes of Java 8 properly. At present, our tool cannot infer the exact type of the generic type, so some modifications need to be done by users. Our tool can generate codes in nested structures and resolve the type to its full qualified name. We keep completing codes and comparing the results with the actual statement, just next to the position where we invoke the content assistance. Beware that, due to the particularity of lambda expressions, the type checking in lambda expressions is not complete, so sometimes users may need to do some modifications to the generated lambda expression. We treat all strings the same, but the concrete values of number literals and char literals are used. The statements generated by PCC in this file are all very long, although our technology is based on small tokens, but the synthesis technology can handle the very long sequence very well. The code on this Java file has no meanings. It is just used to show that our tool handles the new features of Java 8. Our demonstration has 4 phases. Now we enter the first phase. We do not make any change to the original function. Now we have commented out the whole code of a function. The only hint for us is the name of the function. We let PCC automatically write codes for us. You may find that the variable names generated by PCC is a bit strange. To find the meaningful name of a variable in a particular context is another research topic which has been researched before, but researchers in the past did not offer any useful tools for us, so this may be improved in the next version of our tool. By comparing the codes, we find that the result is accurate. Now, we at least achieve the goal of automatically helping users copy and pasting the existing codes. Here is another example. Pay attention to comparing the generated code and the original code. You will find that although the variable names are different, but they express the same meaning. The speed of code completion is very fast, but the process of choosing the suitable proposal is relatively slow. Here, I want to type the ellipsis to express that I would stop here due to the limitation of time, but the internal completion mechanism prevents me from typing that. In order not to affect the following demonstration, we restore the codes to the original state. We keep doing code completion in different contexts. The accuracy is 100% till now. That is supposed to be due to no noise in the context. Let us be quiet and watch the video to see whether all the completions are right. Now we will enter the second phase. In the second phase, we make a big change to the names of the variables in the original function. We are free to make changes to the names of the variables. Due to different names are eliminated in our intermediate representation, called IR, we can prove that there is no influence to the code completion if we change the names as we wish. And it really does. The demonstration shows the completion is still 100% accurate. There may be little difference between the generated code and the actual code due to our fuzzy matching algorithm. In this case, the anonymous class needs to implement the unimplemented methods declared in the interface. Our tool does not auto-implement the methods because there is a hotkey in Eclipse to auto-complete it. Now, let us enter the third phase. In the third phase, we randomly add some strange statements to the original function. We obfuscate the context by adding strange statements such as system.out.println. From the results, we can see that adding strange statements do cause some influence to the accuracy, but in most cases, there is no influence. Now, let us enter into the fourth phase. In the fourth phase, we randomly delete some statements of the original function. In the demonstration, we only delete one or two statements. The accuracy is still very high. But if we delete more than 4 statements, the better results will usually be obtained. It is not easy to choose the statements to delete, because in many cases, deleting a statement may cause compilation errors. We must choose the statement without which no errors will occur to delete. We just comment out a statement to delete it.